Our next eminent speaker is of Goan origin in the US, Andrea Colasso. Andrea Colasso is an engineering lead at Google AR, augmented reality, working on new input and interaction paradigms for wearable computing devices. She spent a large part of her career focused on zero is greater than one projects, turning technology incubation ideas into category-defining product moments and user impact. Andrea has worked on multiple new product categories, AR and VR headsets, handheld controllers, and helped launch new human detection technologies in home devices at Nest. Andrea also spent a couple of years working on AI-powered smart video call framing and human sensing at Portal by Meta. Andrea earned a doctorate from MIT for her work on computational sensing focused on low-powered 3D systems. Andrea combined modern signal processing with off-the-shelf hardware systems to create new ways of sensing objects, features, and inputs. Some of her projects focus on application-specific sensing, where the constraints of the application are incorporated in the design of the sensor itself. Andrea co-founded and led her startup 3DIM team to win the grand prize at the 2013 MIT $100K entrepreneurship competition. Andrea is also an alumni of BITS Pilani campus. She has completed her undergraduate year, and we are pleased to have Andrea live with us. Andrea, hi. Can you hear me?
Yes, I can.
Yeah.
Hi, everyone. It's great to be here.
Come on, students. I want you all to say hi to Ma'am Andrea. Yeah, it's a full house here, Andrea, and we welcome you back to BITS Pilani campus, and we are pleased to have you with us. We will be having an interactive session after this, a Q&A session for you, Andrea, and it's over to you now.
Wonderful. I'm sharing my screen, so at this point, you should start to see a little bit of a slideshow. Yeah, first of all, thank you for having me. I'm super excited to be here. I can see the audience members as if I'm almost there. So Sahil is doing a great job panning and, getting me a live feedback from the audience. So this is great. Thank you very much to the Department of Science and Technology for having me. I'm doubly honored for two reasons. First, as you know, I was born and raised in Goa. A lot of my education and roots are from the state of Goa. And the second reason is it's almost like coming back home with BITS Pilani. As you know, I studied there for my undergrad, and it's super welcoming to be back for these two reasons. Thank you for having me. The rest of my talk is going to be about trends in AI, artificial intelligence, and how that is accelerating our digital future. I've been particularly fascinated with this topic, starting very early with computing, and why do we compute, and why do we use computers, and how does that advance every field that we're making progress towards. So for the rest of this talk, I'm going to cover things about why AI, why computing, how do those two work together. I'll do a very quick primer on AI at a pretty high level, but we'll sort of step into some examples related to object detection tasks. And finally, I want to connect the dots for you with examples of products from my career where both of these have come together to produce some pretty insightful and interesting results that have impact to how humans use computing tools. And so let's start with essentially the motivation of my talk and the motivation of a lot of my work. I believe that transformative computation is currently available in many different form factors. So this is everything from your desktops, PCs to laptops. and things like mobile devices that I'm sure you're carrying with you today. The question that essentially computing is trying to solve is how do we help these devices understand human intent? So one possible way to do that is to essentially basically give humans a tool, give humans a way to input to these devices. So something as simple as a keyboard and mouse found its roots nearly 60 years ago, and we continue to use these tools today. They're very expressive. We are able to code using these kinds of tools. We're able to programmatically tell computers what to do with these tools. To the right, I sort of pulled back an image from roughly 1968, where some of the earliest input devices to computers were just created. But let's fast forward a little bit further. What if you wanted to do more? So, how does this scale to immersive devices? And at this point, when I say immersive devices, it is a topic and a theme that has been present in a lot of the work that I do. It's probably interesting to a lot of you. It is where computing is headed, right? We're always trying to escape from this mobile device form factor and look at things that are more immersive, that are closer to our human vision, that are closer to where we look and see. And so, really, what I'm thinking about here is essentially head-worn devices. So, things like AR, augmented reality, and VR, virtual reality headsets. And so, essentially, the next step in sort of expressing to computers what human intent might be is combining inputs. And when I say multimodal input, I'm thinking about more expressive forms of input like voice combined with vision, combined with other tools. Why is it possible? You'd see that this video that I pulled out is roughly from 1979, came out of MIT. You'll see this person in this chair is trying to manipulate a digital interface by speaking and pointing. So they're using two modes of interaction at the same time. I'm going to let this play for a little bit.
Triangle there. Put a magenta square there. Create a blue diamond there. Move that there.
So, this was 1979, and you're seeing a combination of both the cursor input that is tracking his hand, and you're listening to the speaker also supplementing with voice commands. We're still yet to break through into these types of interfaces where everyone starts to use it in their day-to-day life. And so there are still some challenges. It's many years later after this first initial demonstration of capabilities that were possible. But why now? And why do I believe that we can enable some form of input like this today? The answer lies in AI-driven solutions. It is one of the biggest computing shifts that has happened. And that is essentially what we'll talk about today in the rest of this discussion. So the topic is AI and how it relates to object detection. I sort of abstracted it into essentially the three broad categories of object detection and how it ties to the field of computer vision. As you know, computer vision is a very powerful tool. It allows us to see the way humans see. We have tools like a camera. So to the left end, you see something like image formation that's very close to the physical laws of the world. So essentially, you have an object, you have something that is capturing the world through a lens and sensor, and it is direct detection. Somewhere in the middle, there is a combination where you take something like image formation and you apply low to mid-level vision techniques where you're sort of extracting features and then you're mapping them to specific tasks that you're trying to do. To the right hand is essentially what is the computing shift that we're experiencing today, is where there is an increase in the amount of digital data, and it allows you to do a much better job using AI-based techniques to do things like classification. So the example of the cat is where you're classifying this object as a cat. The example of object detection is where you're able to assign a label to the type of animal that you see in that image. So a cat, dog, and duck in this case. My interest in this field is somewhat at the intersection of combining physical laws and how you represent data with the ability to generate a lot of data and apply AI-driven techniques. So let's cover a few grounding topics. The single object detection, if you had a single cat, you could apply classification and localization, as in you understand where this object is located. And then if you had multiple objects, in this case, you would apply object detection and then instant segmentation to sort of within the pixels identify where exactly this object is located. A few Venn diagrams are in order in sort of giving you basically the lay of land in terms of where computer vision starts to intersect AI, machine learning, and then finally different types of machine learning. Now, even when I was first exposed to the field of computer vision, we were all the way to the left. We were using more traditional techniques. AI, machine learning, and deep learning techniques hadn't burgeoned yet. But today, if you look at where we are at, we're in this middle circle, in this middle column, roughly looking at deep learning. It is essentially the sort of like emergence of a lot of data that is helping us really move in that direction. And then to the right, I'm sort of talking about different types of learning techniques where you can train a model with supervised labels, unsupervised labels, and reinforcement, where you're sort of teaching the model a set of rules that it's learning by examples. So now let's look at a very quick primer on deep learning. Essentially, why is deep learning so popular? The answer is it's easy. And when I say that, I don't mean it in in a light way. I want to contrast why I believe deep learning is easy relative to some of the earlier days of computing. At times when we had less data, there was essentially every step in the computer vision pipeline had to be handcrafted, or techniques like feature extraction. There were very essentially detailed steps that you did have to apply traditional computer vision to. And it was largely a lot of parameter tuning in these steps. Today, there's a ton of data. It's mostly a problem of hyperparameter tweaking. And what exactly a hyperparameter is, we'll talk about in a little bit. The second reason why it's so popular, and I think this one is a little bit more intuitive and you would probably enjoy it a little bit more, is that it works despite the challenges. And what I mean by that is essentially if you had an image of an object, you could very quickly start to incorporate different challenges like viewpoint variation. You could capture a cat from many different locations. You could capture things like lighting variations in the scene. You could look at things like occlusion. You could look at things like displacement, background clutter, and then intra-class variation. So with data, you can provide a model a lot more samples of the object of interest. And so that essentially is indirectly solving this challenge with object detection. And then the next reason, which you would also find a little bit more interesting on why it works and why is it easy, is if you start to look at essentially the curve for deep learning, look at the blue curve that if you follow the blue curve, you'll see that with an increased amount of data learning algorithms. So there's really this big delta you can sort of start to gain in these techniques and then connect them to the problem that we were trying to solve, which in this case was how do you make machines understand human intent? So very quickly, let's take an example of if you were trying to detect a digit. To the left, you have input, which is a 28 by 28 image. Essentially, with a convolutional neural network, what you're trying to do is apply a kernel. A kernel is a type of filter. It can be applied in 2 dimensions. For those that are in high school, essentially, you are probably learning about this as filtering. For those of you that are in undergrad, you're probably pretty familiar with convolutions at this point. So you apply various types of kernels of different sizes, and then sort of have this stack of, in this case, 10 filters. There's subsequent steps where you start to combine. It's called the pooling layer, where you're now starting to combine these into a smaller size so that you're representing these features in, in smaller sizes as you go down this convolutional neural network. You apply a few of these layers and eventually you do end up with a fully connected layer where you're essentially trying to get back to the output, which is going to detect what this number is. In this case, the example is 5. So that's essentially what a convolutional neural network looks like. I told you at the beginning, I was always interested in how this maps to physical parameters. And so this slide essentially talks about the two steps that you're doing. In the first step, you're doing feature extraction. In the second step, you're doing classification. We talk a little bit about deep neural nets. Let's contrast that with convolutional neural nets. We don't specifically have to look at every layer here, but if you're trying to take away the intuition here, deep neural nets have many deep layers. And you'll see, I try to contrast it with the size of the top and the second rows in this image, showing that deep neural networks are not as shallow as convolutional neural networks. You have many more layers that are intervening. Okay. I did promise that we would start looking at physical examples of essentially what the deep net is learning. And so in the case of something like face images, you'd see that in the input layer, you're first learning face features in the hidden layer 1. In the next, you're sort of learning the face itself in hidden layer 2. And the output stage is sort of outputting that you did see a face. Now, I talked about at the beginning, there's always interesting detail when you combine physics, or you combine anything that has to do with physical modeling that you can represent with something like deep neural networks. And so I promised that I would do an example from my career of using deep neural networks for immersive input. And if you look at the left GIF, essentially, you'll see that the user there is trying to create an image in 3D. And you're seeing this controller input start to create this beautiful 3D rendering. So in this part of the talk, I'm going to talk about the work in my career, where essentially we were building tracking technology. And here we were thinking about immersive devices. I started this talk talking about immersive devices, things like VR and AR. Here to the right, I'm sort of referring to a VR headset. And to the left, you're seeing handheld controllers. So it's much like the GIF that we just watched in the previous slide. You're seeing this user here. They have a handheld controller that's allowing them to create these 3D structures in an immersive device like a VR headset. And to the right, what I'm trying to show here is that how would a tracking technology that would enable someone to use 6 degrees of freedom, which means 3 degrees of positional translation and 3 degrees of freedom of rotational variance, so yaw, pitch, and roll. And in this example, we're sort of looking at this headset to the right. It's got a set of transmitters, the controllers in the hand, which were essentially the creator tool in the previous GIF, essentially sort of receiving the signal. So one way to do this is to sort of look at an active solution where you're actively sending out infrared light into the scene. You have these emitters that are spread across a VR headset, an immersive headset, and you have these controllers that are receiving the signal. Each emitter is sort of transmitting a unique code in this case, and each controller is receiving this in sync with the headset. So essentially, each sensor is sort of sampling every single emitter that is emitting a infrared pattern throughout the scene. Now, essentially what you're doing from each of these sensors, it is now a source localization problem. We are trying to convert this raw brightness that you're receiving at each of these sensors, and you're trying to triangulate and report back these 6 degrees of freedom for each of these controllers. So you can think of them like a tool. You're trying to manipulate them in X, Y, Z, and yaw, pitch, and roll. So if you look at just intensities, or this matrix of intensities that you would identify from each of these controllers, the inverse problem that you're trying to solve is the 6 degrees of freedom pose. I talked about, looking at physical modeling. And so this is where it starts to get really interesting. For this type of problem, essentially what you're trying to do is understand what is the underlying physics of this problem and how can you represent it. So as each element in this controller, as you're moving your hands or as you're sort of trying to create, imagine each of these elements is rotating with your hands. And essentially it is following a Lamboscian law of optical physics. And what that means is you have a radial fall off that falls off as a square as you move away from this emitter. It falls off as a square root of the intensity. And then you have the same for the emitter. It's sort of falling off according to this Lamboscian law as well. It's interesting when you can model a problem with the physics behind it, because that's the fun part. That's the part that you can sort of very easily create and sort of forward predict where each position in this 3D virtual grid is going to be. The problem that is hard is the inverse, where you're receiving this data at the controller, but you're trying to now output an XYZ and a yaw pitch and roll. For those of you that are in high school, you're probably just starting to study a nonlinear system of equations or systems of equations. And for those of you that are in undergrad, you're probably finding some of this familiar if you're learning anything related to source localization. Now, interestingly, this is a problem that's very similar to localization as in the more traditional context of GPS. As an example, you have multiple satellites, this source and receiver pairs, and you're trying to triangulate where essentially an object is. Okay, so essentially what we're trying to do when we're converting these intensities back to a pose is find a nonlinear function approximation via some technique. You could apply more traditional source localization algorithms, or you could try neural networks. Now, you might wonder, what exactly would a neural network learn in this case? And so let's take a very simple toy example in one dimension. So you have the emitter, you have the receiver. I talked about the intensity falling off as a square as you move away in distance. So you see the 1/x² here. Now, if you simply took an input layer, an output layer, and a hidden layer, and we started to see some of these in the earlier primer where I was showing you different layers in neural networks, and you apply an activation function at the output layer, what you start to see is that this very simple model learned this inverse square root function. We said that light intensity falls off as a square root of the distance. And so you see that a very simple representation with just 3 neurons in this hidden middle layer starts to learn this inverse square root function. Now let's expand that to a 2D example, because we don't want to work in just one dimension. A similar approach, and you now have a 15-layer hidden layer, and you start to see that you are able to very accurately identify this X and Y coordinates in 2D from this with a hidden layer that has size 15. So you have an input layer with each of these sources that are LEDs. You have each detector that is represented in the input layer as well. And then you start to see that you are able to localize in X and Y. And again, we're still applying the physical laws of Lamboscian fall off. Now, you can make a leap of faith here and sort of believe me in the next few slides that talk about multiple hidden layers. Adding more hidden layers sort of gives you a deeper network, and then you're able to fully output X, Y, and Z and the yaw pitch and roll from this problem. But you might wonder, we talked a little bit about physical laws of physics and how we're able to apply that in the forward model. We talked about the inverse problem. We said that was hard. I showed you how you could sort of learn each of these physical functions representing even a very 1D toy example with just 3 neurons in between the input and output layers. So you might be wondering, well, how do we generate data, right? One thought is that you could bring in people, you could have them use these devices, you could record large amounts of data. But there's another way where you can start to look at synthetic data generation. And this is a lot easier when it comes to problems that are well modeled by the physics in the underlying sensors or the underlying system. In this case, what we ended up doing was basically generate some 5 million poses of each of these locations. We created a 3D voxel grid that was represented in a discretized space around this immersive headset. And we generated all of these poses synthetically. Now, the cool part about generating something synthetically is that if you understand the forward model and you understand the noise model behind it, you can very easily add this noise into your forward model and sort of create a lot of rich labeled data for yourself. So this is another area that typically, excites me. I'm excited about things where you can start to explain physical laws underlying any sensing technique. And also this whole idea of generating data is now a lot more achievable.
Is the first and foremost conditions of developing an attitude towards science. And our curiosity develops when we start doing it with our hand, in our laboratory, or at home, anywhere, and start asking questions, why this happens. Okay? So that's what my recipe towards science is.
Thank you so much, sir. A big round of applause to Dr. Professor Arvind.
Probably in the student building somewhere.
Compute and the architecture that's available to you. And so in this case, you want to optimize the number of parameters. You want to optimize the type of activations that you're using at the end of each of these neurons to sort of make sure it's embedded friendly. So in this case, a lot of fine-tuning or a lot of architecture considerations have to be matched with the kind of compute that you might have available to you. Okay, so now let's see the output of this. We talked about, at the beginning, we saw a user sort of generating this beautiful 3D art. What else could you do if you had AI-driven input immersive computing? You could imagine sort of one person in the left, in the real world, the other one also seeing a virtual representation. You can look at these devices that are generating sort of augmented reality content that you can place alongside your real world. And in the right one, that one's a little bit more playful. It's sort of looking at this Jedi trainer. For those of you that might find that interesting, that's another way to sort of interact with both the real world and augmented information behind it. Now, I want to come back to the question that I originally sort of talked about and help connect it all together. We are at this inflection point where there's a lot of computing options available. There's a lot of compute available. We're trying to make input and more expressive to computing devices. And we're basically trying to capture human intent. So one question that we might ask is, how are we helping devices understand human intent? And to do that, I wanted to give you a little bit of a sneak peek into some of the work that we're doing at the Google AR team, the augmented reality team. We're looking at compute extending out of phones, out of tablets, and into various types of wearable devices that you would wear on your body. And so there's 3 ways to think about it. First, is direct tools. We talked about how computing started with the use of direct tools like the keyboard and the mouse. We also looked at what that type of input means with an immersive system like virtual reality. We looked at handheld tools like controllers. I opened the talk sort of showing us an arc towards multimodal input, where there was a user both speaking to a system and pointing at the same time. So we were combining both of these systems together. But what with something that is wearable, hand worn or face worn, look and feel like if you wanted to provide this type of human intent type of understanding to the system? And so some of the work that we're doing on the AR team is about proactive, contextual, and multimodal input to these systems. And so essentially, what you'll see is a system that is able to understand voice the way it's spoken, a system that is able to understand different languages via an AI model that is able to take any language that you're speaking, detect it, recognize what you're saying, and then translate it into a language that you understand. So this problem is very close to my heart. I think that sort of having this understanding of what people are saying, of human intent represented to a machine and then fed back to another human is pretty powerful. And unlocking that type of interaction with computing systems, I believe, has a lot of potential for every type of system that we build, use, and start to experience. And so I'll play you a little clip giving you a sense of where we're going with this kind of work.
You're looking straight into your eyes, and it seems like you're looking right at me.
Making access to information just instant and intuitive. By doing that, technology fades into the background, and we're more connected with the people and the things around us. Giving people the gift of communicating with anyone, no matter what language they speak.
So I'm going to pause there a little bit and sort of, take it back to the screen. This is essentially the person sort of, seeing subtitles for the world in many ways and understanding what the person across them is trying to speak with them. And that's one of the ways in which we can extend augmented reality to our everyday systems. It's augmenting information in a way that you see it in context. And so it's both contextual as well as augmented. And so I'll continue playing the video.
What language they speak, I think is a really powerful thing.
Que tengo que dialogar con muchas personas que solamente hablan inglés. Como magia para mí, porque voy a ver cosas que voy a entender lo que ellos dicen por completo y
互相沟通。我爱你。
And so that's essentially where we want to get to. We want to get to the place where computing understands the way we understand intent, the way we understand human intent, and sort of bring together all types of systems where you're combining both modalities, you're combining the context, and you're combining various tools available for us with computing to sort of put them together in this one unified architecture, AI-driven computing. And with that, that's the end of the prepared material that I had. I look forward to taking any questions and anything else that we might have to discuss today.
Yes, thank you, Andrea. And students, have you enjoyed this session? Okay, so we will be passing around mics. There are cordless microphones being passed around. And if anyone has a question for Andrea, request you to raise your hand. A volunteer will come up to you. Teachers, please encourage your students to ask questions. Is there anyone? Okay, I will give you 2 minutes to discuss if you have any questions. But Andrea, I have a question for you. And
Yeah, sure.
yes, we are proud of you being an alumni of a prestigious uh, BITS Pilani campus that we are standing in. I'm standing in right here on stage. And your aspiring successful journey to build your career from a young undergraduate from BITS Pilani to uh, an engineering lead post at Google AR. Could you elaborate on how you reached that far so that our young budding students uh, are inspired by you? Yeah, the first question.
Why AI is important?
Can you?
Could you speak into the microphone, please?
Why AI is important?
Oh, why is AI important? That's a great question. So, essentially, if you want to solve a problem, you can think of any problem that you're solving in math. You have various operations. You have a system of equations that you might learn, and you might try to understand, or you might try to compute what the various variables are in the system of equations. A very simple one might be you have a line with a slope and an intercept, and you're trying to with the knowledge of one, you're trying to predict if you had a certain point x on this line, what would y be, right? That's one way to solve a problem. Artificial intelligence is a set of algorithms that's essentially helping you do this kind of operation, which is an inverse problem, on a much larger scale. So you're taking in something like an image and you're trying to detect what object is in that image. So you can think of it as extending a 2D space, and you're trying to identify what each pixel in that image means. So the case where I explained to you a simple linear function like a line, and you're trying to take the slope, intercept, and a coordinate and try to predict or compute the other coordinate, is a very simple way of thinking about how you would solve a system of linear equations. AI is a way of extending this ability to understand what is each pixel behind, say, something like an image. And the way you're doing that is by learning a large set of examples. You're taking a large number of images that, these days we sort of kind of capture everywhere from our various camera devices. We have a collection of these images, and you're able to now, from a set of these images, use AI to actually understand what's in that image. Like, what exactly is this an image of? It's a great question. Thank you.
Thank you, ma'am.
What's your name?
Pushparaj,
And which school are you from?
Keshav High School.
Okay, students, please introduce yourself, your name, and which school you are from before asking your question. Is there anyone else? Please raise your hand. Any student? Yeah. Yes, raise your hand. Yeah. There is a student in front. Yes, stand up and take the mic. Mic is on that side, yeah.
Hi, good morning. My name is Adarsh Yadav and I am from Divyar High School. So my question to you is that will we forget our culture if we go beyond technology?
That's a very good question. Thanks, Adarsh, for that very deep question. Will we forget our culture if we go beyond technology? And I think you'd see in the examples that I've provided, we're actually trying to understand each other a lot better, right? Understanding voice, understanding language. These are things that are helping us keep our cultural roots while also being able to understand and communicate with one another. And so I would say the hope is that technology shifts or the use of different modern tools for computing should bring us closer to our cultural roots instead of forgetting them. Just being able to understand language, which is such a basic and rooted thing, something that's really rooted in culture. Being able to understand different languages and express yourself in a language of your choice while others still understand you. Being able to do that with technology powered shifts, I think is bringing us closer to what we, what are our cultural roots. So I would say the inverse of that is true.
Thank you.
Any more questions? Raise your hand and stand up if you have a question. Okay, I want you to turn around and face, there's a camera over there, so that our guest speaker Andrea can see you. I need you to turn around and face the camera. Yes, I will get to you. Yeah, wait. Stand up, the one who was supposed to ask the question. Yeah, can you give him the cordless mic? Cordless mic. Okay, fine. Yeah, yes.
Ma'am, I'm Hiral from Our Lady of Candelaria High School. I have a question. To what extent do you think AI will be capable of decoding human intent? Can we decode emotions by AI in terms of robots?
That is a fantastic question. Hiral, thank you for your question. I think I talked about, intent very programmatically. So how do you take it and you try to, sort of convert it into a position, or you convert it into an object detection task. But you're asking the next level of understanding, which is context, right? Like, how do I understand a user's emotional state, or how do I understand what the state of the environment the user is in? Are they in a busy street? Are they in a very quiet place? Yes, there are a lot of strides in AI to basically understand emotions, as well as understand scenes and context better. And so what that means is you try to assign not just a label to what the scene is in the moment, but you're also trying to understand exactly how the scene influences the person that is in that scene. The two together will help understand exactly, what is the user's context. And so that's essentially what I was showing in the last slide, sort of proactive and contextual computing. Yes, understanding emotion is a big part of it. I think your question was two parts. Can AI help better predict and understand emotions? And the answer is yes, there's a lot of progress happening in this field. It is called the field of affective computing, where affect is emotion, and you're trying to compute emotion. And so you can tell whether a user is happy, sad, angry, these kinds of primary emotions. The second part of your question was, can you take that and apply it to robots? And I think you're sort of getting at, can you build sentient robots? That one is a little far away, right? Like, we're still sort of unpacking how do we understand how the brain, or the human brain, makes sense of these emotions. There's a lot more progress that needs to happen to sort of take that understanding of emotions, understanding how the brain interprets these signals, and then apply it to a third body, in this case, the robots, as you're thinking about it. But it's fascinating to think about it. AI is driving a lot of the understanding. It's not yet driving the assignment of these emotions into a robot. But engaging in the field of AI, or starting to think about it and research these areas, will certainly help us get there.
Thank you, ma'am.
Yeah.
Thank you.
Yeah. Yes.
Hello, my name is Fran Vaz and I am from Regina Mundi High School. And my question is, how can AI be utilized to protect data and prevent hackers?
If I understand your question correctly, how can AI be used to protect data?
Yes, so like users' data, emails, passwords.
Yeah, that's a great question. In fact, a lot of the roots in security and privacy that have to do with cryptography, you can sort of build systems that are resilient to attacks. You can build AI that is approaching this problem of privacy and security from two ways. One is preventing attacks by actually giving AI a lot of samples of what bad actors or bad examples look like. And then the second one is like actually building in techniques that help create more cryptographically strong approaches to protecting things like private data or personally identifiable data. So there's two ways to think about it. One is in giving AI samples of what bad attacks look like, so that the next time something like that happens, your AI model is able to detect the presence of a bad actor. One example I can give you is, this one is a little bit more manual, but CAPTCHAs, where you're sort of like in a website, it's sort of telling you identify all of the traffic lights in this image that you're given to sort of understand if you're a bot or you're a human in the loop. And so this kind of a task AI would be very good at doing, and sort of recognizing the patterns where a bad actor is trying to like impersonate or log into somebody's account that in a fraudulent manner. So that's one example. The second example is a lot of internet transactions that happen for various reasons, and I'm using transaction in a very broad sense, also have patterns and sort of give the ability to collect these types of patterns and train models to understand temporal context, like what would step 1 and 2 look like if behavior was fraudulent, and what would step 1 and 2 look like if it was truly an intent that the user made. And so I think this is a very actively researched topic. So I'm glad you asked. You can definitely approach it from two ways. One is AI to sort of enhance cryptographic approaches to securing data, and the second one is AI to detect the presence of any bad or fraudulent activity.
Okay, thank you, Miss.
Yeah.
Thank you.
We'll just take another 2 questions since we are running short of time. Yes.
My name is Aditya Kushwaha of class 7th. My question was that AI is very useful in our daily life, but can be there any disadvantages of AI in technology or some other things?
That's, again, a very deep question. Thank you. With every technology shift, there's always 2 ways it can go. There's advances that we're hoping to make with technology, but there are some unpredictable ways in which technology can behave. And so it is important that when we build tools like AI, we understand its scope and limits. One example that may not be as catastrophic is if you're using AI to predict a random variable and it's sort of giving you some answer, but that answer is incorrect. So if it's incorrect and it has less bearing to what you're actually trying to do, it might have very low consequences. But let's say you were trying to make a prediction about whether I should pull a drawbridge up or down, and there was a car trying to cross that drawbridge. If you made a wrong prediction, there's a much higher cost to that wrong action. And so there's for every useful piece of technology, it's always 2 sides. With AI, what we strive to do, or what every AI researcher strives to do, is understand what is the accuracy or what is the precision with which you can build models. And within the scope of precision, you try to understand what are some false positives that might actually be pretty catastrophic, right? So it is true that every model has huge capabilities that it's bringing with it, but there's always a small percentage of incidents where you might have a false positive, or you might have a negative answer that can have consequences. And so engineering is this field of problem solving where you solve both the positive cases as well as the false positives. And yes, it can have negative consequences, but how robustly and how comprehensively you train AI can help minimize some of this impact.
Thank you, ma'am.
Yes.
Thank you.
We will have the last question from the student on top.
Good morning, ma'am. My name is Mainur Khan. I am from Keshav Smriti High School, Vasco, Goa. I have the question that is AI costly? If yes, then how can we common people use it?
Yeah, that's a good question. Is AI costly? There's different answers to depending on what part of the pipeline you talk about. Is data costly? Yes and no. For some problems, if you look back at what I talked about, I said the availability of data, the increased availability of data is what is making AI more potent or making AI more possible. Is data costly? Yes and no. Sometimes it's available freely. Sometimes you have to spend a lot of money annotating or labeling data, in which case it does have a cost associated with it. The second type of cost is in training of these models itself. Typically, these models are trained with some pretty powerful backend machines. Sometimes you have custom TPUs or tensor processing units that essentially are helping you train these models fast with very large amounts of data. So we're thinking on the order of not just gigabytes, but often terabytes of data that are used in training. So that's a costly operation. And then the third type of cost is in execution of these models. So if you want to make a prediction of something, you have a model running somewhere, there's cost to execution. So it's sort of like taking some amount of compute. The good news is that for a lot of these tasks, there are a lot of models that are pre-trained. So they exist. A lot of large companies in the industry have done the work of, sort of creating these labeled data sets. They've done the work of training these models and sort of have created these pre-trained models. And so if a student somewhere in the world is trying to leverage AI or learn from AI, you can always start with pre-trained models that exist, right? So you sort of don't have the cost of creating data. You don't have the cost of training the model. You can start with something pre-trained and experiment and sort of go from there. That's an indirect way of saying that there is a baseline and you can work from that baseline pretty much for free to get an understanding of what AI can do for your problem. Where you meet the problem is in sort of like learning coding or learning programming so that you can start to experiment with some of these tools.
Thank you, ma'am.
Yeah, we have one last question from our venue in charge, Sahil Kamath.
Yeah, hello, Dr. Andrea. Finally,
Yes.
I take immense pleasure to ask you the final question. First of all, I would like to thank you because you have given a wonderful lecture, delivered an amazing session, and I think children have equally enjoyed because you have answered each and every question which was present in this venue. I'll ask you a final question, straight cut question I'll ask you is that where do we see AI 30 years from now?
Yeah, great question. AI would have probably transformed into the next
gesture of appreciation for this captivating talk.
very early results in this space. And so I believe that that would really push us or push AI to its next state, in my opinion. And you can think of all of these tasks that we're doing that are very linear, sort of farmed out to quantum computing tools where there are parallel instances of the same task happening. And so my belief is that that's the next frontier, and it's super exciting. And I look forward to someone from this audience, sort of pursuing that as a career.
Andrea, I'd like to now invite the director of BITS Pilani, Professor Suman Kundu, to give you a vote of thanks.
Hi, Andrea. Hope you can see me. Yeah.
I can.
Yeah.
Hello.
Yeah. We are really proud of you. You are our alumna. So thank you for taking the time off to deliver a very inspiring lecture. It must be very late in the night for you. However, you have done the job. You have inspired the students and motivated them. There are a number of questions, and the questions can keep on, coming. However, what I would request you to do is to be on the campus as well at the earliest. So we would love to have you on campus and interact not only school students from Goa, but also our own students on campus who are really motivated when an alumni is on campus. Thank you very much. Thank you very much for doing this. Thank you.
Thank you. Thank you very much. It was my pleasure. And I really enjoyed interacting with everyone today. Thank you for having me.
Students, I want all of you to put your hands together for Andrea Colasso. And like to, in a very special way, thank Andrea Colasso. It's almost 1:45. It's 1:45 a.m. back in the US, and we really appreciate you having given us the time to deliver this session. Moving forward, we have our eminent guest speaker, Dr. V. Kamakuti, and may I request Director of BITS Pilani, Professor Sumant Kundu, to kindly escort Dr. V. Kamakuti to the dais. Put your hands together, ladies and gentlemen, students. As I'd like to now invite Mrs. Bharti Nayak to present a floral bouquet to our guest speaker. Please put your hands together. May I now invite Director of BITS Pilani, Professor Sumant Kundu, to introduce our guest speaker.
Thank you very much. Good afternoon, students and teachers. Hope you are enjoying the sessions and you can see the benefits of artificial intelligence. It's 1:45 a.m. in the night and she still looks as fresh, as it should in the morning, and delivered a wonderful lecture. So far you had all the lectures delivered to you virtually, right? Using online platforms. So this is the first talk. We have Professor Kamakuti with us in person, and I think you'll enjoy it as well, right? Are you inspired? Are you happy? Yeah. And we do conduct various events here on campus of BITS Pilani, and we'd like your teachers to contact us so that we can do more for you. Okay, we are a very well-known, very well-regarded science and technology institute of the country right here in Goa. And we do conduct and organize various events for you to motivate you to take up science and technology as a career course. And we have various projects that our students undertake, various creations that they have that we do demonstrate to you, and hope we get an opportunity to do that as well, from drones to robots, to whatnot. That's what we do as a Science and Technology Institute. I'm sure you have all heard about IITs, Indian Institute of Technologies. Many of you probably aspire to study in IITs or BITS. There's an IIT now in every state in India, right? And as you know that IITs have done very well for us, very well regarded all over the world, right? And to represent IIT, we have with us none other than Professor V. Kamakuti, who is the director of IIT Madras, right? So he's here with us since morning. I will introduce him very briefly. Professor Kamakuti received his master's and PhD degree in computer science and engineering from IIT Madras itself. He joined the faculty of IIT Madras in 2001 and took over as its director in January 2022. As you would understand, he specializes in the area of computer architecture, information security, and VLSI design. Those will be big words for you, but hopefully you'll understand them better as you grow and as you hear him speak. He heads the microprocessor development program and the Information Security Education and Awareness Program at IIT Madras, funded by the Ministry of Electronics and Information Technology, Government of India. He is a member of the National Security Advisory Board. He was also the chairman of the Artificial Intelligence Task Force, Artificial Intelligence yet again, constituted by the Ministry of Commerce and Industry, Government of India. At IIT Madras, he has served as the chairman, JEE, and as Associate Dean, Industrial Consultancy and Sponsored Research. He has over 150 publications in international journals. I think that you would know that as researchers, we need to publish our papers in journals, and he has published 150 of them, and guided many research scholars for their PhD and Master of Science program. He has coordinated and successfully delivered close to 50 projects from industry and government R&D establishments, huge accomplishments. He serves in the Technology Committee of the National Stock Exchange and Reserve Bank of India, so very, very diverse, talents. Dr. Kamakuti is the recipient of DRDO Academic Excellence Award, Indian Electronics and Semiconductor Association Techno-Visionary Award, Abdul Kalam Technology Innovation National Fellowship, SCCS Lifetime Achievement Award, IBM Faculty Award, and the list goes on, right? We are very happy to welcome Professor Kamakuti to the campus and to Goa, and we invite you, the stage is yours, the floor is yours. We invite you to excite and motivate our students and interact with them. Thank you so much, Professor Kamakuti.
Heads of the department, principals of other schools and colleges, teachers, and students for being present here on this auspicious occasion. We hope that the time that you have spent on this campus attending to 3 sessions, one from Dr. Christopher Brett, will definitely ignite some passion in terms of being the future scientist. There's a lot on your shoulders, and we hope that you will grow and shine like stars today and always. Thank you. I request our dignitaries to be escorted for lunch.
Which are still not available, right? And all these things, as a country, we have addressed this challenge in a very, very nice manner, and we are now moving into the last 25 years of our 100-year journey after independence. And this is what we call as Amrit Kal. And as we will touch 2047, 1947, we got what we may call as the social and political independence. And when we touch 2047, we need to have technology independence. And who is going to fight for it? So, what I thought that I could present today is what India is doing today that will enable you to launch this battle, the fight for technology supremacy, the legitimate fight for technology supremacy. What is it that is available to you on which you can launch this fight? I thought across the 23 IITs in the country, what are some things that we are doing? I wanted to share with you so that you could make an informed decision in your career as you are now, many of you are in, how many of you are in 9th standard? Wow, it's all 9. Then 10th, 11th, 12th. No. Very good. So as you are moving within the next 3 to 4 years, you have to make a career decision. You all should make an informed career decision, and that is what I want to present here. What are the things that are happening? Will it be interesting to you? Good. Can you all tell me how many people want to study computer science? No one to study computer science engineering? How many people want to study biology? Which is better, computer science or biology? Biology. Why is it better? Computer science gives you more marks, easy to study. Biology, in your CBSE, how many people are from CBSE? CBSE school, state board school. No answer. Which school, which board do you belong to? Goa board, that's the state board, right? So in biology, you need to memorize at least 500 jargons. Computer science, you need not, so it gives you more marks, right? Where do you want to do biology? Huh? So why do you think biology is important? Can anybody tell you? Today, we are all talking without mask. Many of us are alive because of what? Because of corona. Because of what? Vaccine, correct? And who found out this vaccine? Biology or computer science? So which is better now? Good. How many people, 10th standard, after 10th standard, how many people would go to biology? All of you said you want to study biology, only 4 people are saying answer. Okay? So, what did India do? I want to give you some very interesting statistics. When the Western world developed vaccine, and the vaccine started working at 8 degrees centigrade, which was suitable for their country, they stopped any more development. Can we bring an 8 degrees centigrade working vaccine to India and administer? Can we? Yes or no? No. Okay, so what did we do? We made a vaccine, not one, two vaccines, and administered to how many people? Can you just estimate? 110, 200 crore people, 200 crore shots have been put in the country. 200 crore. And not only we did for our country, we also gave it to the other parts of the world, many times free of cost, and that is India. Correct? If we really aspire to become a technology super leader in 2047, this is the spirit in which we need to work. We need to work for technology for all, technology for social benefit, technology for the entire planet. We are not a country who will do something for ourselves. When there is a need, where there is a social need across the globe, India will be the first country to respond. And that's the same spirit in which let us develop this 25 years of Amrit Kal. Will we do it? Good. Now, what are all the interesting things that are happening? I just want to go through a lot of things so that you just get an awareness across disciplines, like what you can do after +2, right? Which engineering you can select, right? Some ideas will come here. We are now moving towards Industry 4.0. Industry 1 was basically developed because of steam power, the water. You in your old movies, 65, 70 range movies, you will see that steam engine moving, pulling a train. That was Industry 1.0. Industry 2.0 was primarily powered by electricity. Industry 3.0 is primarily powered by computer and automation. The Industry 4.0 that we are now going to witness is going to be powered by what we call as cyber physical systems. What is cyber physical system? A system that you have in your hand which is also connected to your internet. What is an example of a cyber physical system? Can anybody tell? Very good. Mobile phone. How many people do not have a mobile phone? Oh, there are still some people. Good. Okay, digitally hiding yourself. Very good. Now, when we look at this world of cyber physical system, what is the G in which your mobile is going to work? We have worked on 2G, 3G, 4G. What is the next one? 5G. So 5G is not just an entertainment plus, like you get a video high definition TV. It is not just entertainment plus, it is going to be an economy changer, right? And what we see here, we have applications of that in agriculture, application of that in financial technologies. Many of you pay your fees, your mother, father will pay the fees through, mobile phone. Logistics, Uber, Ola, those exist in, right, in Goa, right? No Uber or Ola. Dangso. Goa Miles. So you can book your taxi online and it comes. So logistics, healthcare, right? In pizza, yeah, that's more important. Pizza will come by ordering in the internet, right? So that is logistics, healthcare, right? Today you can do remote consultation, you have a lot of devices, you put a watch, it will tell you how much you have walked, how much you have slept, right? And then there is space technologies, rockets. I'll tell you a lot more of important things. So these are all the application areas that are going to be benefited because of Industry 4.0. And then you have lot of techniques that will help to build these areas. And these techniques are, just now you heard a lecture on artificial intelligence. There's something called data science. I'll explain about this very shortly. Then simulation and modeling. Security, you all do a lot of work. How many people know about hacking? You all know about hacking? Okay. So what is the recent hack that has happened in the country? Big one. AIM server got hacked, right? So we need lot of security and intelligent manufacturing. So these are all some emerging techniques. What you learned today is about, in the previous talk is about artificial intelligence, but there are a bunch of things that are going to enable these very, very nice application areas. And then to implement these techniques, we need lot of basic building blocks that starts with high-speed internet access, that is very important, where we are looking at 5G, 6G, etc. Then very high performance computing. How many people use Gmail here? All of you use Gmail. Where is your mail saved? In some server, right? So that server is a high performance computing server, right? Where all your mails, hundreds and thousands of mails of millions of users are saved somewhere, and whenever you access it is giving you the answer, right? It gives you your mailbox. So high performance computing system, sensors, IoT. IoT is Internet of Things. This is an Internet of Things. Today it is connected to, I have a remote and I can basically control my slide to this, right? And embedded systems. And there are a lot of things that we are looking at, including advanced materials and renewable energy sources. 3D printing. How many people have seen 3D printing? All know about 3D printing? Okay. So there are many basic building blocks. So what I will do is, in the next 5 to 10 minutes, talk about what India is working in these areas and these areas, right? So we will have a quick glimpse so that when you finish your +2, you can go into mechanical engineering, you can go into electronics communication. Of course, you can do some amount of AI, computer science, but lot more of civil engineering is needed, lot more of mathematics is needed. So we'll see, and lot more things that are going to come. In addition to this, so let me give you an example of a cyber physical system. How many people have used Arogya Setu? Okay, good. So how does the Arogya Setu work? When two people have installed Arogya Setu and they come in close proximity to each other, the Bluetooth should be on. There's a Bluetooth, right? And the information, let us say A and B come close together. B's identity is stored in A, A's identity is stored in B. And in case A tests positive, then the server, the cloud, high performance server, will pull all the data in A's mobile and it will find B's data also. Then there will be an analysis done, how long this person was there, where he was, and then if there is a necessity, the server will warn, somebody to whom you went close someday has tested positive, so you also please test, go and test yourself whether you have any COVID or not. So this is how it works. So there is a sensor, there is a mobile, there is a server. So this is how a cyber physical system will work. And more than 19.5 crore users are using Arogya Setu. This is one of the largest software that has been, the largest mobile app that has been launched, and this whole thing was developed within a short span of 21 days, right? And this is a very big achievement as a country, and this involved not just software engineers, but it involved legal experts because personal data is being handled. It involved lawyers, it involved epidemiologists, it involved many people to basically come out with this type of a system. So Arogya Setu is a very interesting example. Now, the next important thing is about medical sciences. Today, there is a need for everybody to, technology to start looking at medicines, right? Now, across the world, in India it is just catching up. Across the world, there have been very strong relations between technology people, technologists and the doctors. And these people collectively, they are called as physician scientists. And one of the interesting data that we have is 37% of the Nobel laureates in the country, Nobel laureates in the world are such type of physician scientists. They are the people who found these causal relationship that sugar causes diabetes, smoking causes cancer, drinking causes liver damage. These type of cause-effect relationship was actually being proposed and found out by these type of physician scientists. So there is now a need in our country that we start understanding how our body works. What is the mathematics, physics, chemistry, biology behind how our body, the working of our body, how is glucose regulated in our body, what is the relationship between brain and liver in the proper distribution of glucose. Many such very interesting questions come, and that is where a very strong relationship between medicine and technology needs to be developed. So by the time you all come to your +2, there will be at least 3 or 4 IITs and Indian Institute of Science will start offering undergraduate programs that will expose you to medicine and technology and their interface. And people who are opting for biology, I'm sure you will certainly benefit by this type of courses. Today, everything has become interdisciplinary. For example, I say I am a computer scientist, it doesn't mean anything, right? I am an engineer. That's the name, that is the spirit in which we need to work. And whatever we try to do, like for example, if you take the Arogya Setu, a computer scientist alone could not have made that Arogya Setu. It needed lawyers, it needed people from humanities, it needed communication engineer, it needed sensor experts who can work on Bluetooth sensors, it needed epidemiologists who are doctors. Even to make this simple one-page describable system, we need at least 5 to 6 disciplines. And all the IITs today are now moving towards what we call as this interdisciplinary education. So when you are working for these competitive examination, you will get some rank, that's called karma, and by that rank you will get some course. But it doesn't matter what course you get, because all the IITs, many of the IITs, including IIT Madras, within the end of the second year, you can go and choose something that you like. You may like computer science to start with, but by the end of second year you may hate it. but you can now go and do some advanced materials. So this interdisciplinary education is coming up, essentially blurring the differences across the departments. And that is something that we need to capitalize. And all of you now must concentrate on looking at systems in general and see which aspect is interesting, because any rank in a competitive examination cannot be a limitation for you to choose whatever you want to do. So let me come to the data science. IIT Madras opened a very nice data science program which does not have any age gap. There is no JEE requirement. You have to write a simple qualifier, and there are multiple exit options. 1 year you can do what you call as you get a certificate. The second year you get a diploma. The fourth year you get a BS degree in data science. And we have admitted around 16,000 students. 1/10 of that population came one day to IIT, and this is just a photograph to tell you. Data science essentially becomes extremely important in today's context. Today, with so much digitalization happening, your health record, the vegetables that you buy, because if you buy it online, the time you bought this, time you are traveling, your air ticket is bought online. So many details about you are available, and people actually use these details to basically enhance their business. They would like to find which part of the time or which part of the year Goa will get so many people, which duration of the time there will be traffic in a particular road. So these type of very interesting questions come up, and data science is the answer today. So the University Grants Commission of India, recognizing that there is a need for interdisciplinary education, has come out with a very interesting order, in my opinion an historic order, which says that you can do 2 degrees at the same time. So you can, provided the timetables don't clash, and no university can stop you from doing it. So you can do a basic degree, say for example commerce, or you can do a degree in music, but in the evening you can actually do a degree in data science, and this will be a great combination together. So this is one very important career prospect that you can have. And these are some of the very interesting initiatives. Of course, this is something about quantum distribution, and your own IIT Goa is actually doing certain fundamentals and characterization of emerging quantum materials. So today the computers that we have are digital computers, and the tomorrow's computer are going to become quantum computers, and for that quantum computers we need hardware, we need software, and there are some work that is happening across India on this. Medical, this is a very interesting solution by IIT Bombay, where there is a CAR-T therapy which is for cancer, and the cost of that was approximately 5 crores per patient, but it gives you a very good relief from cancer. The IIT Bombay effort has brought this cost from 5 crores to 15 lakhs per patient. And this is a major achievement, and this now has become a very good startup, and they have raised more than $9 to $10 million. And this is how, so friends, understand that by making an Atmanirbhar technology, an Indian technology, the cost reduction can go down from 5 crore to 10 to 15 lakhs. And today, India, with the population, with the income limits, we need to give affordable health care to every citizen of this country. These type of efforts are mandatory, they are needed, otherwise India cannot scale to that expectation. And working towards these indigenous technologies is extremely important, and the next 25 years thrown in front of you, this is one very interesting, important challenge. But these type of case studies also give us encouragement that we can achieve this type of devices and cost. A lot of work has been done on low-cost ventilators. What you see there is a fabric which can basically reduce the virus, and then a lot of things on smart healthcare where artificial intelligence is used to basically detect some diseases based on the reports, etc. This is a very interesting thing. How many people know Ramayana? Right? So this is a petal from Himalayas which could have, which was COVID, which was basically handling, which was showing certain very good effective solution to COVID. When to cure Lakshmana, Hanuman actually took the Mrita Sanjeevani from Himalayas. So when we look at this, our country has so much natural resources that we have so many herbs there, many things unexplored, and those things can basically be a very, very big contribution back to the world. The next thing that today, to make life good, is assistive technologies, right? So so there are many things happening here. I'll give one example. What you see on the top is the Neobolt motorized wheelchair. And this is a wheelchair where you sit down, a patient who has not, a person who have never stood up in their life, right? Actually was sitting on the chair, and then you press a button, the chair will lift him and make him stand. Right? And so one of the touching moments for this, on the inauguration day, the persons were also sitting on the dais, and when the national anthem was sung for the first time in their life, they all stood up, and it was very touching for us. So these are some things which can basically change the life of many, many people, can make a difference. The artificial feet, which is currently under production, is very, very cheap. When you go and import this, it goes to lakhs. When you make it in India, it comes to thousands. Then the next thing, why are we all earning money? Why do you want to earn money? Ultimate use of money is what? What is ultimate use of money? Huh? Buying pizza. Right? To fill this 6-inch stomach, right? So you have to fill it with good food. So who is the king here? Farmer is the king. All of us sitting in this AC room, we are all slaves. The farmer says, I will not produce, you will not have one grain to eat, correct? So as a country, whom should we dedicate ourselves to? Farmers. Okay, and then, great. Now, these are all some of the great efforts that are being happening on trying to double or triple the farmer's income and reduce the amount of fertilizer that we put in our soil. Because the fertilizer is what? Poison. Okay, so we need to reduce the chemical fertilizer and bring in natural fertilizer and organic farming, and there are a lot of work that is happening in this area specifically to improve the farmers' revenue 2 to 3 folds, and that is the aim of our Honorable Prime Minister. And this is something, a lot of work are happening. IIT Dharwad, IIT Roper, IIT Madras, and many other IITs are looking at this. And then this is about 3D printing. I will quickly go through this. This house is printed by a 3D printer. Okay, you give the concrete as a material, and then you give the sketch to the 3D printer, it will automatically print this house. So this is something very, very interesting. And this if you come to IIT Madras, you can see this nice house there. And then there are a lot of work happening on what we call as smart materials. Today I need to conserve energy. I need to conserve the amount of electricity I spend. So today there are very smart materials which when the sun rays come in, they will filter the UV so that the heating happening inside the room reduces. So there are smart construction materials that are happening, and this is where the entire civil engineering is going ahead. So if you get into civil engineering, you are blessed, and that will be a great thing here. I'll just take another 5 minutes to wind up before we take some questions. space becomes extremely important, right? Today, we are in 5G. What is after 5G? 6G. 6G will not be a terrestrial network alone. It will be a hybrid network. There will be some communication going to satellite and it will beam, right? And so that means we need to, there is a calculation done in which we have to send around 1.2 lakh satellites within the next 5 years. How many satellites? 1.2 lakh satellites in the 5 years. How many days we have in 5 years approximately? How many days we have in 5 years? Let me say 250 working days per year. Into 5 is how much? 1,250. In 1,250 days, if I want 1.2 lakh satellites, how many satellites I should do per day? Huh? Array, mathematics. Simple maths. 1 satellite per day. So 1,25,000 satellites in 1,250 days. How many satellites per day? 10 na? 100 satellites per day. And we have how many? Say 8 hours. Okay, across the globe, say, let us say 24 hours. 24 hours means how many satellites per hour? Around 5 satellites per hour. Right? Right? So approximately every 15 minutes one satellite should go so that we meet that requirement. And the lifetime of these satellites are going to be 5 years. So every 5 years we need to keep resending this. Okay? So that means what we need is a rapid launch facility. Now what we are doing at IIT Madras is this rapid launch facility where we are, for us to send rocket, we need to make rocket. To make a rocket today, make a rocket engine, there are more than 3,000 soldering points. It takes 3 months. All this we have now made it into 3D printing, and a 3D printed rocket can be made, an engine can be made in 72 hours. We can make 4 rocket engines in 72 hours. And we can scale it to, if I have 10 such printers, I can make 40 rocket engines in 72 hours. And these rocket engines are needed, if I want to send every satellite 15 minutes, I need those rocket engines. So these are some of the big challenges that is put in front of us, and that is going to be a very, very important thing. So if you come to IIT Madras, we will show you something called a rocket factory where these rocket engines are being printed, 3D printed. You just give them some metal powder and what comes out is a very beautifully printed rocket engine. So this is another thing, and a lot of work is happening on mining. So if you have an opportunity, rare earth metals are extremely important today. Today, lithium ion, I think one of the first to talk from chemistry, there was a big statement about lithium ion. Today it's called white gold. So rare earth metals are becoming extremely important, and so mining is a very interesting field. If you get into ISM Dhanbad, where you do an excellent mining course, is one of the world-class courses there. And then the last one, 5G communications. 5G, till now, in the several decades of history of communications, we never had an Indian standard in the international forum. With the 5G, these institutions, IIT Bombay, Kanpur, Delhi, Hyderabad, IISc, Samir, along with IIT Madras, have now got the first standard essential patent into the international standard, which is a very big feather in the cap for India. And that is a very great achievement for the country, because if we want to really become superpower, we need these type of patents so that people, when they use it, they need to give us some revenue back in this direction. So 5G is a very, very interesting. So if you get into electronics and communication, antenna designs, analog design, these are going to be an extremely thing. The last one is this Hyperloop project at IIT Madras. What is Hyperloop? From Goa to Chennai, we can go in 70 minutes, right? In a train, right? Hyperloop is a complete vacuum tube on which the passengers are seated inside in a pressurized cabin, and and in a sort of a bus, we call it as a pod, and then it goes at a speed of around 500 to 600 kilometers per hour. So this is on the thing. So this is something, yeah, very interesting development. We will be having the first of its kind in Asia, a 550-meter track where this Hyperloop demonstration will be done, and competitions can be held within the next few months. Then there are a lot more of initiatives specifically from the high altitude. Today, our soldiers are really sacrificing. They are sitting on, the high altitude mountains, braving all the hostile weather with very, very limited food quantity, and they are all spending all their time to give us a very peaceful sleep in the nights. They are awake 24/7. So we need to do something. We as a nation are committed to do something for our beloved soldiers, and a lot of work is happening in this direction, specifically on the high altitude side. And if you ever get an opportunity to work on these type of high altitude technologies, please do dedicate yourself, because if that saves the life of one soldier, I think we have done a great service to our nation. So with this, I end my talk. Thank you very much.
Thank you, Professor Kamakoti. And we will now have a round of questions. If anyone has questions, students, we have a teacher. We have a teacher right here with a question. Can you please bring the mic down? Oh, okay. Ma'am, we'll first take a question from top, and yeah.
Yes. My name is K. Narayan Pai. I am alumnus of IIT Madras. Hello. Yeah. My name is K. Narayan Pai. I am alumnus of IIT Madras. Sir, actually, I wanted to ask this question, like, why there is more number of kind of schemes and grant for biotechnology than getting IP-based software product?
I didn't get your question.
Meaning, like, whenever we see that is like BIRAC, then a host of other schemes.
No, let us not talk about grants here. This is basically education. We'll take your question later, kid.
Yes, ma'am.
Yes.
Can you bring the mic in front, please?
Yeah, there is a kid here. Please get up.
Yeah, please stand up. Please stand up.
Yeah.
Hello, sir. I am Prajakta Goltikar from DPR High School. I am studying in 9th standard currently. I just wanted to ask a slight bit question. Why are Indian rockets failing at a certain point?
Huh? What is? I'm not getting the...
Can you talk slowly and clearly? Yeah, slowly.
Sir, why are Indian rockets failing at a certain point?
Why are Indian rockets failing? Indian rockets, every rocket in every country has failed. But there are a lot of success, right? For example, even the Chandrayaan, it had reached only around 10 meters close to the surface of the moon. And that's a huge success, correct? The reasons why these technologies are facing, we can't say. What is fail? F-A-I-L is first attempt in learning, correct? Fail is never failure. Fail is first attempt in learning. That's what Dr. Abdul Kalam has told, right? I borrow it from him. So we have had several first attempts in learning. Reason is the space is unexplored, right? And when one rocket goes, the second rocket goes, the environment there, the actual parameters there are unknown, right? So, in spite of it, there had been lot more of study that has come. Recently, 32 satellites have been put on the satellite. Okay, so there was one or two failures that will happen because it is an unexplored area. And if you don't fail, you never learn, correct? So space technology, India can be proud of two technologies. One is space, another is nuclear, right? And we are marching ahead, and we will see lot more success in the coming days to come.
Thank you, sir.
Thank you.
Ma'am, your question?
Good afternoon, sir. I'm from DPR school.
Where are you? Yeah.
So my question is that, of course, not questioning the IITs, but most of the professional colleges are teaching the same old pattern and old technologies, and children or educationists have to. I should say the ones professionals have to go abroad to get their fantastic degrees. Like one of the example is our own Madam Colasso, who had been Andrea Colasso. So I think the technology that has been, we need to really teach the children the latest technology in every field.
Yeah.
So can you just highlight on this, sir?
Yeah, I'll highlight on this. See, first and foremost, after your BTech examination, there is a need for you to write an examination called GATE. People fear that GATE. Even in why IITs became famous, 1998, Narayan Murthy came out and said that his son has applied to IITs and he has Stanford or one of the US schools as plan B. And then he said, oh, he didn't get there, he got there. Correct? The main issue here is that we are a large population. There is a need for us to filter in a legally and fair, acceptable manner. So entrance exam cannot be dispensed of. That's why we bought other courses like data sciences, where you just need to write a qualifying examination, but this is a large course that we are trying to handle. This is one part, number one. The number two is about the syllabus, right? What we have done as educationists, I cannot go to a university and ask them to change, right? It is for the university to have the sense to change it. But what we have done is, as early as 2005, we have started a program called National Program for Technology Enhanced Learning, NPTEL. Today we have more than several lakhs of hours of lectures that have been, the exact teaching that we do at IIT, the exact courses that we teach at IIT, we have recorded it and made it available. We have got a very, very extensive discussion forum where people can ask questions and we give back the answers. And during the COVID, we had more than 1 million people who have been benefited out of it. Even so, as a result of it, UGC came out, AICTE came out with a regulation which is responsible for this, that every college can have at least 20% online based on some of these inputs, and many colleges now and universities now are accepting NPTEL as a degree, as a course. If you take a NPTEL course, that marks will be considered towards your degree. That credit transfer has started happening, wherein we try to start upgrading the syllabus. Okay, so India as a country, we have been pushing the frontiers of research. Given the huge population and our different social needs, the amount of money we could get for research funding is limited. But within this limitation, we have done work. It's not that we have not done work, we have done so much work. But it is for the youngsters to take up this competition, do that work and come to these Indian institutions. Just as an example, I have not gone abroad, I don't have a passport. Thank you.
Okay. I just want to know how many more questions are there. Please raise your hand. So 1, 2, 3. Okay. So we will take another 3 questions. One more? 4. Okay. So we will take just 4 questions. Okay. Before we felicitate our distinguished speaker. The question on that side. Yeah.
Good afternoon, sir. My name is Sneha Sheth and I am from MS Higher Secondary. My question starts from, as we are going closer to technology, we are getting even closer to disease and environmental degradation. Why is it so?
Yeah, so in spite of technology, we are getting more diseases. First and foremost, we really don't know whether that technology that we have is actually handling the diseases at all. One of the biggest things that we are realizing as common man, common patients, when we take a medicine, it gives it, for example, you have a headache. The medicine that you give will stop the headache, but it doesn't remove the real reason for that headache. The real reason can be a gastric problem, it can be an intestine problem, it can be a, many other things. There is a very, very limited understanding from the medicine angle on what could be a correct diagnosis for a disease. I know from my own family, we have not diagnosed properly and we have lost lives, right? So this is the prime reason, and that is one important reason why we need to start as engineers. Hope you all come to engineering, or doctors, you start looking at these two disciplines together, right? When we start saying medical and technology, the technology starts hue and cry, oh, nothing we are doing, and doctors say, oh, what is there in technology, right? That should stop, and people have to start looking at it together and understand the human body as a mathematical model, as a chemical model, as a physics model, as a mechanical engineering model. And once you start understanding the relationship between the different parts of the body, that is where your diagnosis itself can become proper. Our Indian school of medicine, the Ayush, how many people know Ayush? Can you put hands up? Ayush, you know, Ayurveda, Unani, are supposed to address the root cause of the problem. The Nadi system, which people, I don't know whether you have gone to an Ayurvedic doctor, they catch your, with the 3 fingers, they measure your pulse. There are 7 degrees of measurement, and a very big expert can go up to that 7 degrees of measurement. That's what I'm told, right? And if this can basically diagnose the root cause reasons, and people can go to that root cause. But these systems, unfortunately, we are to establish the scientific mechanism for it. Then only it gets acceptance across the world. So there is a need for to sum up the question, the answer that I could give you, there is a need for engineers and doctors to break their silos, break their egos, start understanding that they don't know anything about that field, and with that fresh mind, open mind, they have to start working together, and that is where the world will benefit.
Thank you, sir.
Yeah, who's next? Yeah, we will just take 2 more questions because of time restraint. Okay, so yes.
Good noon, sir. My name is Sahi. I'm from Keshav Smriti High School. So my question is, can computer science make artificial hearts? If yes, then can a person stay with it?
Yeah. Okay. Can we make artificial organs in general? Right? So again, the answer to her, the same question I gave. In 1960s, I think Kennedy and Cooley. Kennedy was a president. He said, our next biggest challenge for the next 50 years is to send a rocket to the man to the moon. I think Cooley also said at the same time, the next biggest challenge for us is to make an artificial heart. This happened in 1960s, if I am correct. Okay, in the 60 years, 50, 60 years, yes, we did send man to the moon, but we are not able to make an artificial heart. There are some efforts, it goes, then it fails, then it goes, we are not seeing that, right? The reason is, again, the same answer, doctors and engineers have not joined their hands together. They need to start holding their hands much more deeper, and not just cardiologists and engineers, but everybody, a generalist, we should now call them as generalists who understand every part of the body. We need to make something called a health stack. There is some molecular genomics, etc., which is the foundation. Then there's a physiological modeling that comes as the next stage. Then there is pharmacology and this device development, and then finally there is a treatment, right? So there are 4 stages in medicine. The physiological modeling is completely missing, and that is why we are landing up with all things. Today we even get imported blood pressure thing, and I know I am very cool, but this shows some 200. But I know that I am really tensed, it shows some 80. Okay, so these are some of the very important things that we need to keep. So addressing it, will a perfect artificial heart come? Yes, it can come. When you, as a biologist, if you become a doctor, learn engineering, If you become an engineer, learn medicine. And everyone, many of you do, it can come, number one. Number two, when that such perfect systems come, right, can the longevity be increased? Yes, it can be increased. If there is a heart failure, it can be increased. But I don't know whether they will survive for long, because every death is not just because of heart failure. It can be because of a failure of multiple organs, and the organs fail not just by themselves, because some other organ is not working. If heart doesn't work, then kidney fails also, because it doesn't get blood. So, or oxygen. So these are some of the big interrelation. Finally, can we make, so as the man grows, keep removing one organ, put another organ, and slowly make them a robo? Then I don't know whether that is possible. And if such a robo exists, what would be the equivalent for brain? That is also something very interesting. And when we bring brain, what will be emotions? So many interesting things can come. But this is a very broad answer to your question. Right.
Sir, can I have one more question?
Yes,
sorry. We are running short of time. We'll give an opportunity.
One more question, let him ask.
Okay,
please,
fine.
Please ask.
Sir, can we insert a computer in our human brain?
Yeah, nobody has understood the brain. The computer which actually bet Kasparov needed one full hall of servers with a very big power substation. But the human brain works, they say in the peak, they say some 20 watt of power, it's just less than your hand, right? So that's the size of the brain. So nobody has still understood the human brain. But lot more of very mundane rule-based work or some pattern recognition, yes, the AI engine is doing now. Many of you would have looked at ChatGPT, the OpenAI. You can go and converse. You can ask about today's lecture. That will give a description of it. So there are a lot of things that are happening. But the thing is, whether the entire human brain can be replaced with a computer, it is very, very far, in my opinion. We have not even understood brain as a model. And especially the power consumed, I drank one small tumbler of milk today morning. I am still talking. But if a computer has to teach, it has to take several watts of power. So the low power that this brain is consuming, from an electronics perspective, we say, that's still unimaginable.